Hello, hello, hello. This is Science Professor Bene, or you can call me Coach. All right, and today we are going to talk about the scientific method writing project. I'm going to go over it for you to get better understanding of the scientific method writing project. So the scientific writing method project, students will read the article, testing on twin astronaut give insight into health tour of life in space. And this is the article you see on the right hand side. And students will do paragraph 1, paragraph 2, paragraph 3, and the concluding paragraph, 4 paragraphs. All right, so students will read the article, then they will incorporate everything they learned in class to write, to complete this writing project. All right, so let's get started. Paragraph 1. But before we even start paragraph 1, this writing project is all about two identical twins. One of them went to live in space, one stayed on Earth, and they were trying to find out the effect of living in space on the health of an individual. So Scott Kelly went to live in space. And here, what can you observe, or what do you observe? Who is taller? The one who went to live in space, who is Scott Kelly, he is an inch or so taller. So he went to live in space for almost a year. And the observation, after coming back from living in space, the observation we make is that we can observe that Scott Kelly has grown taller than Mark Kelly, an inch or so taller, and his face has become a little puffy. So this is our observation from the article, from the image. This is what we see. And based on this, that's what we are going to use to write our scientific method writing project. All right, so let's dive into paragraph 1. Paragraph 1 says, define and explain the scientific method or process. And this, we've done it in class. And we said that the scientific method is a system of standard steps people use to answer testable questions. Then you are done. The next is, it says, state the steps of the scientific method of conducting investigation. Here are the steps. First steps, you make observation, you ask testable question, you state your hypothesis, you conduct a controlled experiment to test your hypothesis, analyze and interpret data or your result, then finally you draw conclusion. So with this, what I expect you to do is you can combine step 1 and step 2. You can combine step 3 and step 4. I want you to write it in sentence form. Okay? I don't want the bullet point or numbered form. Okay? So take note when you are writing your final or your drafts. Okay? Let's continue with paragraph 1. Paragraph 1 also says, based on information from the article, state your observation. And we have made our observation already. Based on this image and also information from the article, we can observe that Scott Kelly has grown an inch or so taller. So Scott Kelly has grown taller than his identical twin, Mark Kelly. So that is the observation from the article, from the image. The next is to differentiate between inference and observation, and make your inference based on your observation. So this is the observation. To observe means you are taking a closer look at something, whilst inference is drawing conclusion based on what you observe. All right? And based on information from the article and also our observation, we can infer that the less force of gravity in space makes you grow taller, because there is little force of gravity in space compared to on Earth. That's the reason why Scott Kelly grew an inch or so taller compared to his identical twin brother who stayed on Earth. So we are done with paragraph 1. Let's go to paragraph 2. Paragraph 2 says, explain what a testable question is in a scientific investigation. When we talk about testable question, it's a question that explores the effect of one thing on another. A testable question is a question that has the cause and the effect. And based on our observation from the article, the testable question is, does living in space affect your height? We have talked about this in class already. The next is to cite evidence from the article to support your observation and testable question and explain. So when citing evidence, you need to say according to the article, or the article states that, and remember your detail or your evidence needs to be in quotation. Okay, so you need to cite your evidence correctly. The next is explain what a hypothesis is. A hypothesis is a statement that can be tested. The hypothesis from our test-based observation and testable question is, living in space affects your height. Remember, our testable question is, does living in space affect your height? So you are changing that testable question into a hypothesis. And if you change the testable question into a hypothesis, the statement or the hypothesis will be, living in space affects your height. The next is to convert your test base into a hypothesis. We have done that. The next is to explain how the experiment is conducted and controlled. This experiment is a controlled investigation or controlled experiment. And in a controlled experiment, only one variable is tested. Only one variable. And here we are testing or investigating the effect of living in space on height. That is the variable we are testing. And we say it's a controlled experiment because we are testing only one variable. So that means we are done with paragraph 2. Now we move on to paragraph 3. Paragraph 3, first bullet point, it says, explain how the control group is different from the experimental group. When we talk about control group is a group that does not receive what you are testing. The experimental group is the group that receives the variable you are testing. Okay? And in a controlled experiment, the control group or subject is treated the same as the experimental group, except that on the variable that is being tested. That means that the identical twins, they are identical in almost every aspect, in almost every way. But the only way they are treated different is that the experimental group, which is Mark Kelly, went to live in space. And the control group, Scott Kelly, the experimental group, Scott Kelly, let me go back. The experimental group, Scott Kelly, went to live in space, while his identical twin brother, Mark Kelly, stayed on Earth. Mark Kelly is the control group. Scott Kelly is the experimental group. Okay, so the control group is treated the same as the experimental group. The only exception is that Scott Kelly, who is the experimental group, went to live in space, whilst his identical twin brother continued to stay on Earth. Okay, so they were measuring the effect of living in space on height. Okay, so that's the only way the control group is different from the experimental group. All right, so we are investigating the effect of living in space on height. And it's only the experimental group or the subject that receive the variable or the condition being tested. In this case, the condition that we are testing is the effect of living in space. So that's the reason why we didn't send Mark Kelly also to live in space. We sent only Scott Kelly because he is the experimental group. And that's the way the experimental group is treated differently from the control group in this investigation. The next is explain your evidence. So you need to cite evidence. Say cite evidence from the article to connect with how the control group is treated differently from the experimental group by sending one twin astronaut to live in space and one to stay on Earth. Okay? So you need to cite evidence to support the control group and the experimental group. And the fact that the experimental group went to live in space. So that's the evidence. When you read the article, that's what you are searching for. That's the evidence you need to search for. All right, let's continue. Let's move on. Then also, after citing your evidence, you need to explain your evidence or your detail by identifying the control variables. Okay, you need to identify the control variable. When we talk about control variable, they are the things we keep the same in both the control group and the experimental group. So in this experiment, there are certain things we need to keep almost everything the same. The only thing we are changing is the experimental group. It's a variable we are testing. So the control variable, they are the things we keep the same. The control variables in this experiment, they are the same kind of DNA. They are identical twins. So they are alike in almost every aspect. So that means they have the same, almost the same DNA. Same identical individual. Their height was the same before the start of the experiment. And also same height at the start of the experiment. They had the same height. Okay? Almost everything about them was the same. They are identical twins. So we can just assume that they had almost the same genes or the same DNA. Same identical individual. So when we talk about control variables, they are the things we keep the same in both the experimental group and the control group. And in this case, the control group is Mark Kelly, who stayed on Earth. The experimental group is Scott Kelly. Okay, so that's paragraph 3. Let's continue with paragraph 3. The next is to differentiate between dependent and independent variable. Okay, when we talk about dependent variable, it's what we measure or observe. Okay, in this investigation, we are measuring the height of the individual, the control group, and the experimental group. The independent variable is what we change or what we manipulate. Okay, so in this investigation, what we change is where they were staying, where they were living. One went to live in space, and one stayed on Earth. Okay, so in this investigation, the dependent variable of what we are measuring is the height of the twin brothers. That's a dependent variable. That's what we measure. That's what we record. And the independent variable is the amount of time living in space. Okay? Scott Kelly went to live in space for almost a year, and he grew an inch or so taller. Okay? So that's paragraph 3. We are done with paragraph 3, and now we go to the concluding paragraphs. So guys, it's so easy. All right? The concluding paragraphs, it says, explain how the data is collected and analyzed in the experiment. All right? So the kind of data collected was measuring the height of both twin brothers every 2 weeks during the time of the investigation. That is the kind of data that we collect for our purpose of investigation. And how do we analyze the data? We look at the data every 2 weeks when we record their height. We should be able to see that Scott Kelly, because he's living in space, his height is gradually increasing. So that's the data that we collected. All right? The next is, does the result or outcome of the experimental data support the hypothesis? All right? And our hypothesis is that if you live in space, you grow an inch or so taller. All right? So the hypothesis for this investigation is, if you live in space, you grow taller. Did this happen? Did this come to pass? If you look at the identical twins, you can see that Scott Kelly, who went to live in space, has grown an inch or so taller than his identical twin brother, Mark Kelly. So that means that our hypothesis is supported, okay? Based on our results that Scott Kelly has grown taller, our hypothesis is supported. If you live in space, you grow taller. And based on our data and observation of the heights of the twin astronaut, the hypothesis is supported or not supported. In this case, our hypothesis is supported. Okay? Then the next thing you do is you need to restate the important points that build and reinforce the test as a whole. Okay? Then you also highlight the significant or important main ideas. So here, you are just writing your concluding statement. And this is the scientific method or the scientific process, the project. And this has been Science Professor Obene, or you can call me Coach. And thank you for watching. Thank you for listening. Take care.